I will just come.
Yes.
Yeah. Yes, Lalit. Yeah, can we start?
Hello.
Hi, Lalit. Are you there?
Yeah. So I have started recording also, and I have opened a Jamboard also, which is shared with you. And,
Okay. You have shared in this one. Okay,
yeah,
fine.
and now I will share my screen also. Hmm.
Yeah, great. Okay, so I don't want to get from the start.
Okay.
I mean, a few things are in the start I understand.
Yeah.
Uh, but I leave it to you. I mean, it is if you want
Okay.
to go with the flow, then it's fine.
Yeah. So we will start from scratch only.
Fine.
So
Okay.
so this is yeah. Okay. So this is our neural network. There are two hidden layers and one output layer. This is input. This is H1. This is H2, and this is our output layer. Here we
Right.
give H0, we get A1, we get H1, we get A2, we get H2, and here we have got activation function as sigmoid, and here we have got softmax. So here we get A3, we get H3. Now sizes also I will write again 5 into 1, this is 4 into 1, this is 3 into 1, and this is 2 into 1.
Okay.
Now
That's just a choice you have made, right?
yes,
Five into one.
yeah. So just
Okay.
for the explanation part, and in fact, I have sent you one that also, one NumPy, that Jupyter notebook also of the same example.
Yes. So that one has, I think, 10 into 1, I think, in one of the.
Yeah, just I will open that also. So here was I have defined the functions. Input size 5, hidden size 4, hidden 2 is
Okay.
4, output size is 2. So the
Okay.
same example I have taken.
Fine. Okay. Great.
And then weight 1, weight 2, weight 3, and biases I have randomly chosen, and then I have taken the shapes also. So these are the shapes again. So now, so that day we saw that A1 is equal to W1 transpose into H0 plus B1. Okay,
Yeah.
and H1 is equal to sigmoid of A1, and size of both will be 3 into 4 into 1. This is clear.
Yeah. When you say both H and A, right? H1
A1,
and A1.
yeah, A1 and H1.
A1 and H1. Yes.
A2 is W2 transpose into H1 plus B2. H2 is equal to sigmoid of A2.
Correct.
Size will be 3 into 1. And A3 is equal to W3 transpose into H2 plus B3. H3, which is nothing but Y hat, is equal to softmax of A3. Size will be 2 into 1. So this is for the forward propagation.
Right. A3 size will be, I
2
think,
into 2 into 1.
1. Okay. A3 and H3 are same.
Same. Okay.
Okay.
So now from here W1 size will be 5 into 4, W2 size is 4 into 3, W3 size is 3 into 2.
Right.
Bias 1 size is 4 into 1, bias 2 will be 3 into 1, bias 3 size will be 2 into 1. Okay.
Correct. Okay.
So this forward part, okay, there is no problem.
Yeah, there is no problem in that.
Oh, oh,
Yes.
yeah. So now we go to next page. Now we'll do the back propagation in this. So when we do the forward propagation, all these values which are there, for example, we have calculated A1, H1, A2, H2, A3, H3. We store them in a cache, store them
Hmm. Okay.
because they will come handy when for the back propagation. Okay, so we do one by one back propagation. So here we had got, for example, we have got H3, which is nothing but your y, and here there is a y, and this is coming to loss. So
Correct.
loss function is your cross entropy loss, which is nothing but minus y into natural log of y. Okay. Now
Okay.
we our objective is to update these values.
Right.
So we start with W3 and B3. So for W3 and B3, we need gradient of loss with respect to W3 and gradient of loss with respect to B3.
Right.
And then W3 will become W3 minus learning rate into loss of W3. And B3 becomes B3 minus learning rate loss of B3. So first we consider the output layer. For this again, W3 and B3 is output layer.
Okay.
Okay. So we have to find WL, for example, by W3. So this we break it. Loss is given by this function. So we will break WL by WA3 here.
Hello. Hello. Hello.
Hi Anand, can you hear me? Hello.
Yeah, yeah. I think the connection was. Yeah, I can hear you now.
Yeah. Okay. Okay. I'm just writing on the chat. Okay. There is an electricity failure at my end actually.
Okay, you are doing it through mobile. Okay.
Yes. 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 So that's why it has become slightly this. But can you see my screen?
Uh, yeah, yeah. I can. So, are you writing in the mobile? Hello. 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 Hello.
Hi, Anand, can you hear me? Hi, Anand, can you hear me?
Yeah, yeah, I can hear you now. Yeah, I can hear you now. Yes. Do you want to do it later then?
Hi, Anand, can you hear me now?
Yes, Lalit, I can hear you.
Yeah,
Yeah.
thank you. So,
Uh, is it okay if we continue now, or should we?
no, no. If you can hear me, then we can continue. You can see my
Yeah, yeah,
screen.
I can hear you well. Yes.
Yeah, screen is visible.
Yes, it is visible. Yes.
Okay. So we had come here. So del L by del W3 we can write down as del W L by del W y hat, del y hat by del A3 and del A3 divided by del W3. This is we are
Yes.
using chain rule.
Correct.
Okay. Now, uh, there are two parts. Okay, today I will explain in detail. So, first part, okay, like this is one, this is two, this is three. So, for
Okay.
one, L is equal to minus y ln y hat. Therefore, del L by del y hat becomes minus y divided by y hat. This professor has also written it as minus 1 divided by y hat.
Y hat. Yes.
It is 1 where y is equal to 1, then 1, else 0. Okay.
Yeah.
Now we come to the second part.
Now,
Sec-
when you do this differential of over this one, the
yes.
symbol one, right? What
Okay.
happens to that?
We are not doing any differentiation. This y, this when we are taking this del L by del y hat, this is
Okay.
you can write down it as minus y, minus we can take outside. It will become minus y del y hat by del y hat plus y hat del y over del y hat. Okay, so this will become minus. Now this will become y into 1 and this will become y hat into del y by del y does not depend on y hat. So this will become 0. So this is actually minus uh, y hat. Oh, y, sorry. I have written somewhere loss. Y into y hat. Okay, yes. Just give me 2 minutes. I'll use eraser. This differentiation part, okay, this del L by del y hat,
Hmm.
L was okay. Just right here. See, y is a constant here.
Right.
Y is a constant here. So this becomes
No, I think the part you erased is fine, right? That.
yeah. So this
uh,
becomes minus y, and when we
ah,
take derivative of this, it will become y hat. Okay. So we can write down this as minus y over y hat also. But professor he has written because see y can have only two values. Y has only had 0 or 1. In case it is 0, then this entire part becomes 0. If it is 1, then we can write down it as minus 1 over y hat. So this value is 1 if y is equal to 1, and this is 0 if y is equal to, sorry, this is 1 and this y is equal to 0. This is how we can write down this.
Yeah. Okay. 1 second. So in the, I mean, when you corrected it, now I
Yeah.
think you meant to also write dou L of dou y hat, right? I think
Yeah.
that part was missing.
You see, this
So you,
is
you wrote you wrote loss equal to minus y ln of y hat.
this, yes.
Yeah, and
So
it should
so dou del L by del y hat will
y hat.
become del by del y hat minus y ln y hat. This y hat is a constant, so this y comes out, minus also comes out,
Right.
and del y hat of ln of y hat. When we take a derivative of log, so this is y. When we take derivative with respect to log, so it becomes 1 by. I'll just write down here.
Yeah, I got it. I got it.
Yeah, so this
Yeah,
will become
I got it.
minus y by y.
Yeah,
Okay, which also can be written as this thing.
minus one by y hat. Yeah.
But one, okay, this is a different one.
Okay.
Now we will come here. I'm just explaining, but for the course part, okay, you will have to just remember this part. So second part comes of a del y hat over del a 3.
A3.
Now,
Yeah.
yeah.
Yes.
So now see, this y hat is also a vector. It will be something like this, two values. For
Correct. One
example,
zero
yeah,
or
no,
zero one
no,
like that. Hello.
0.5, 0.5. Hello, Anand, can you hear me?
Yeah, I think I lost you in between.
Okay,
Okay.
so it can be like this. Some will be like 0.4, 0.6, or it will be like 0.75, 0.25, because it is a softmax function.
Ah, okay, okay. So it is
Okay.
applied over that 10 or 01. So it will
No,
be
no, 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 no. It will not be applied over 1001. I'll just tell you. We'll go to this. Y hat we are getting here. This is H3.
correct. So A3 will be something like I mean from I'm referring to the document you wrote not the document
Yeah.
but the previous classes
One.
notes we wrote it down, right?
Yeah. Yes.
So
Yes. One example we had taken.
yeah, so
No.
in that example you have written A3 could be 10 and on that
Yes.
you applied the softmax and you
Yes.
wrote 0.73 and 0.73 something you wrote.
Yes, yes. So we will do one example also. So
Okay.
just to understand, so y hat size which is there, it is 2
Hmm.
into 1. Okay. And we are taking derivative of this y hat with respect to a3. The size of this is also 2 into 1.
Correct. Yes.
Okay.
Yeah.
So when we take derivative of this, so I'll give you an example. And so we have to do dou y hat divided by dou of a3. So we are taking a derivative of a vector with respect to a vector.
Yes. Okay.
Okay.
Hmm.
And now let's just take an example that we have got a y hat was size of 3, for example. Like
Hmm. Hmm.
A3 had two terms like A31, A32, A33, for example. Okay.
Okay. Okay.
Then y hat will become e to power minus a31 divided by e to power minus a31 plus e to power minus a32 plus e to power minus a33. This
Okay.
will
Yes.
become e to power minus a32, and this will term will become the same.
Correct.
This becomes a minus a33 divided by the same term. Okay.
Right. Right.
This is H3. Now, when we take this is, for example, this has become y hat. Y hat is equal to this. Now, I have to take derivative of y hat with respect to entire A3.
Okay.
Okay.
So y
A
hat is nothing but point 3, point 3, point 3, right?
मतलब in some example it can become क्या? It will depend on the value of A31. If A31, A32, and A33 they all are same, for example,
Oh,
if they
okay.
are 1, 1, 1, then it will become 0.33, 0.33, and 0.33.
Okay. Okay. Yeah, yeah. I missed it. Yes.
Yeah.
Correct.
Now, when we take this del y hat with the entire vector del A3, I have to take derivative of this. It means, for example, it will be del y hat by del A31. Okay, del y hat del A32,
Hmm.
del y hat del A33. It will be something like this.
Right.
So let's just take an example of del y hat with del A31. Now this y hat also has got three components: y1, y2, and y3. This, for example, I
Right.
can call it y1 hat. This I can call y2 hat, and this I can call y3 hat.
Okay.
So
Yes.
this y1 hat which is there, it will get derivative for all three.
Okay.
Del A32 also, del y hat, del A33 also.
Okay. So
Okay,
del
so
del y one hat and right. That's what you mean, right? Del
yeah,
y one
yes.
hat by del A31, del
Huh,
y1 hat by del A32,
huh,
and del y1 hat by del A33. Okay.
yes.
So this will
So
be a matrix or something.
no, no, it is a we call it something when we do a derivative of a vector by a vector. So, for example, this is a vector, one, two, three values are there, and
Hmm.
we are taking a derivative with respect to this vector. So, this will get, इसका derivative will be done with respect to all three.
Yes.
This also will be done with respect to all three. This
Correct.
also will be done with respect to all three. So, this.
Correct.
So, we also can write that this y hat 1 which is there and y hat 2 which is there and y hat 3 which is there will get derivative with respect to a31 all three.
Yes. Correct.
Okay, so now can I erase this again or no problem,
I,
we'll continue है ना?
yeah. A little bit there. Yeah.
Yeah, so now just take one example of when we are taking with respect to a31. So let's take example of del y hat with respect to del a31. So in this there will be three parts. Del y1 hat by del a31, del y2 hat with respect to del a31, and del y3 hat with respect to del a31. These are the three conditions.
Right.
So first we take first one. This you don't have to remember. I'm just explaining. Otherwise, there is a quick formula for this. So
Okay. Okay.
y1 hat is equal to e to power minus a31 divided by, which I can write as a minus a31 plus e to power minus a32 plus e to power minus a33, and I can use minus 1. That's
Okay.
okay.
Divided by. Yes. Correct.
So now when I take del y1 hat by del e to power a31, so this is also a function of A31 and this entire term is also a function of A31. It is there.
1 second. So
Yeah.
why did you write in the denominator? Why did you write dou e to the power of a31?
Sorry, my mistake. My mistake. This
Okay.
is A31.
Dou
Okay.
a31. Okay. Okay. Okay.
Okay. And now what do we do? We use the formula of del of AB. We can write as del A into del of B plus B into del of A.
Right.
Okay. So
Correct.
this will become the e to power minus a31 into del of a31 of e to power minus a31 plus e to power minus a32 plus e to power a33 minus 3233. Okay, plus e to power minus a31 plus e to power minus a32 plus e to power minus a33 into del of del a3 e to power minus a31. I can write down this
Mm,
using this
okay, you
formula.
are using that previous. Okay, A dou B dou by. Okay, plus. Okay.
B do it, है ना? So now, when we expand this, this will become e to power minus a31. Now this is
Okay.
a whole term. So here minus 1 will come here. Then this term will come minus a31 e to power minus a32 plus e to power minus a33. This will come minus 1 minus 2. Is this clear?
Okay. Yes.
Okay. Now we come inside this. So dou of A31 E minus A31 with respect to A31 will become E to power minus A31. Is that okay?
Okay.
Okay.
That's because e to the power is has the same derivative as
Yeah.
it's.
And then we go to A31. A31 derivative by A31 minus will become minus 1.
Hmm. Okay.
This is clear. And now
Okay.
here this will become minus e to power A31 plus e to power minus A32 plus e to power A33. Now here it will also become e to power minus a31 and minus 1. This is clear?
Second one is 3 1 and 3 1. Okay. Yes.
Yeah. Now see this part which is there, this I take outside. So I take e to power minus a31 into power or this is minus 1. So I can take it outside. So this will become e to
Your
power.
voice is you are not very audible, Lalit.
Yeah. Is it audible now? Again actually
No.
power filter is taking place. But Jamboard is visible?
Yeah, I can see the Jamboard. Yes.
Okay. So this part I have taken outside only up to here. Okay.
Okay.
So here what will remain? It will remain e to power minus a31 divided by e to power minus a31 plus e to power minus a32 plus e to power minus a33 and this will become minus 1. This is clear
-1. Okay.
because this
Uh,
entire part I have taken outside.
okay.
Okay.
Right. Okay.
Okay. So this
Okay.
you can,
This can you just make some one small correction that the inside the parenthesis
yeah,
inside the brackets the
yeah,
denominator the last term it's 833, right? E to the power minus 833.
3. Yes. Okay.
Okay. Yeah. Okay.
But this term, what is it? It is y1 hat. Okay. And this is
Okay.
also y1 hat and minus
Okay.
1.
Oh, that's how you are getting this. Okay.
Okay. So this is the first part. So this is when this was dou of y hat with respect to dou of a31 y1. Okay.
Uh, I didn't understand that part. Can you?
Okay. See, what we had written that to take dou y hat by dou a31, I have to take dou y1 hat by dou a31, dou y hat 2 by dou a31, and dou y hat 3 by dou a31. This we have calculated first part.
Okay.
Okay. So when, so we can write down that when this first part we were like it was like this y1 y2 y3 add. When I take off with respect to A1, then it becomes Y1 y hat minus 1. Okay. Now we come to the second part. Let's see dou y hat 2 by dou A3 1. Because this will also have derivative.
Correct.
Okay. So let's see. Now y2 is nothing dou A3 1. Y2 is e to power minus A3 2 into power e to power minus A3 1 e to power minus A3 plus e to power minus A3 3, and this I can write down minus 1. Is this clear?
Yeah.
Okay.
Okay.
So using the same formula, it will become e to power minus A3 2 will become e to power यहाँ पे minus 1 will come power minus A3 1 plus e to power minus A3 2 plus e to power minus A3 3. Here it will become minus 2. And see, when I take a derivative of EA3 EA32, then it will become my e to power minus A32 into minus 1, and second term will become 0, because when we take derivative of e to power minus A32 with respect to A31, then this term does not depend on A31, so this term second becomes 0.
Okay. And just give me 1 minute. I'm going through this little slowly. So,
Okay.
e to the power.
Okay, I will write down elaborately. Actually, one
No, no, no.
step
It's
I.
it's okay. Lilith, it's too much trouble for you. I'm
No, no,
giving
no,
you
no, no, no,
already.
no, 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 no problem, no problem. See, if it becomes clear, then only it's okay. Otherwise, then there is no use. So what I will do, I will again use the same formula. Dou of AB is equal to. So this will become e to power minus A32 dou by dou A31 of this entire term, e to power
Yeah.
minus A31 plus e to power minus A32 plus e to power A33 minus 1, then plus, okay, then this entire term e to power minus A31 plus e to power minus A32 plus e to power minus A33 into dou of e to power minus A32 by dou A31. Okay, so now when we open this will become A32. Now I do the derivation of this.
In the second term,
Yeah.
uh, you should be writing this to the power of -1, right? The
Yes.
e
Yes.
to the power.
Yes. Minus 1. Yeah.
Okay.
Okay.
It looks like both are inside the bracket. Can you close the bracket above the -1?
Okay.
In the bracket, in the previous step. Yeah.
This is okay.
Yes. Yes. Okay.
Yeah. Okay. Now we do derivation of this. So minus 1 will come here. Then this will become e to power minus A31 plus e to power minus A32 plus e to power minus A33 minus 2. Now we go inside. So I'll get e to power minus A32, and then I will get minus 1. And see, this term will become 0.
Which one? The second term?
Yes,
No, the second term is. Ah.
because e to power minus A32, if we take derivative with respect to A31, there is no relation. So it is 0.
Right, right. So, just 1 second. E to
Yeah.
the power of minus A32 into -1 minus 2.
Okay, I have
E
committed
to the
one. I
power.
have committed one mistake here. Here it will come A31.
A3. Yeah, that's why
Yeah,
I
yeah,
was
yeah, yeah,
thinking.
yeah. So it is a.
Sometimes when you write so elaborately, the small mistakes will
Yeah,
come,
yeah,
and then I just hung up on these small
yes.
problems. That's yeah.
So this
Okay,
second
got it.
part becomes 0, it is clear. So now when we open this, minus 1, this becomes plus. So I can write down this as e to power minus a31 divided by e to
Hmm.
power minus a31 plus e to power minus a32 plus e to power minus a33 into e to power minus a32 into e to power minus a31 plus e to power minus a32 plus e to power minus a33.
This is a to power. Uh,
This is minus 2.
oh,
So
okay. You are splitting it. Okay, okay,
yeah, spread.
okay. Got it.
Now
Okay.
see, this part is nothing but it is y1 hat. This is
Okay.
nothing but it is y2 hat.
Hmm.
So
Hmm.
this will
Hmm.
become
Hmm.
y1 hat into y2 hat. Okay.
Okay.
Okay. Okay. Now similarly, when we do dou of y3 hat by dou a31, it will become y1 hat into y3 hat.
Hmm. Hmm.
Okay. So what have we realized? We have realized that dou yi, for example, this is I, by dou a, for example, I say it as j, for example, it has got two conditions. First condition, it becomes yi hat into 1 minus yi hat when I is equal to j.
Hmm.
Otherwise, it is becoming yi hat into yj hat.
Hmm. Okay.
Okay, from these
Very,
conditions.
very interesting. Yeah. Yeah.
Yeah.
Okay.
So this also I can write down as using something called y1 hat. There is a symbol like this. I am forgetting the name of this, and this is yj hat.
Hmm.
Okay.
So you mean both these conditions can be written in a single
Yeah.
equation, in a
This
single
is,
formula?
yeah. Then when I is equal to j, then it
Oh.
can be written as 1. This also yi. And this is 0 when I is not equal to j. This we can write down.
Oh. Okay.
Can we see that if this becomes 1, then it becomes y1 1 minus y1 hat. Okay, because I is equal to j. So j will
Hmm.
become I,
Hmm.
first condition. If it is 0, then it becomes minus yj hat. So we are forgetting somewhere minus term. Okay, this minus comes here. This minus term is somewhere. I think we have missed out some minus somewhere. Are we forgetting some minus 1 here? This is okay. And this minus, okay, y hat minus 1 की जगह 1 minus y hat feared. So this is okay. This is clear, okay? This one final, okay, which we have got.
Uh, yeah. So, I mean, why is the difference?
No,
In
no.
the previous one, uh,
Uh,
w-
See, in the previous one, this 1 minus y hat which is there we have got y hat minus 1.
uh, okay. Can you go back?
Yeah, y hat minus 1.
Mm,
Okay,
okay.
so we,
Y1 by E31.
yeah, so this was y hat minus 1. So take out this minus here. There is some symbol problem is there somewhere. Yes, okay, we can see that, okay, where it is a problem. But from here, okay, a very important thing which is coming, we don't have to remember this entire derivation. Nothing to remember throughout the course. Only what we have to remember, that now del L by del A3 which is there, it has become now minus y over y hat, this we had got the first part,
Hmm.
and this we write y hat I dou ij minus yj hat. Just give me 1 minute, Anand. Somebody has it.
Okay.
Marco. Hi Anand, can you hear me?
Yeah,
Hello.
yeah, I can hear you. Yes.
Okay, so
Yes, I
before
can hear.
proceeding, yeah, so before proceeding further, we'll just check, okay, that minus problem. So here we had got, okay, this was this was clear.
Yes.
Okay. Now second part we got very clearly here, minus one had become this become y1 minus y2. So this is also very become clear. So here it should be y at minus. So here it should be y I minus 1, and here y I equal to j. So here we can write this as, this we can write down, had written, is equal to yi ij hat minus this ij. Okay, and this ij
Okay.
is equal to 1 when I is equal to j, and it is 0 when I is not equal to j. So when, for example,
Okay.
we can see the first condition, when I is equal to j, this will become 1, this will become yi hat. So this becomes the first equation. When
Okay.
it is
Yes.
not 0, so then it becomes yi hat into y hat j, the second condition. So that's how it is gets represented like this.
Okay.
Okay.
What is I and J again? Can you?
I,
Uh,
I, I and j is like this. I'll erase that. That when we take a derivative of a vector, there is a vector,
yeah.
and we
Uh,
are taking with respect to another vector.
hmm. Okay.
So, so this value which is there, it will get derivative from by this also, and by this also. In this
Right.
case,
Right.
for example, y1 hat is depending on a31, a32, a33.
Okay. So the so can I just tell I is the basically the index in the y vector, the y
Yes,
hat vector, and J is the index in the a
yes,
vector.
yes, absolutely, absolutely.
Okay.
Okay,
Is it possible to write that somewhere? Would you
yeah,
mind?
yeah, yes, yes. I'll write down. I'll erase this and just.
Are these explained in the lecture also? Because there is a lot of
No,
derivation
no,
there.
no. A lot of derivation is there, but they have not explained it like this. They explained
Ah,
in a
okay.
very, very different way. So I'll change
Okay.
the color also. So I is index of y hat, and j is index of a. Is that okay?
Yes, that's fine.
Yeah.
Thanks.
So from here, when
Hmm.
we take this, so del L by del A3 is equal to, we are getting from del L by del y hat and del y hat by del A3. Okay.
Hmm.
And A3 has had three terms. 1, 2, 3. Okay. So this we get here, we replace it here. So this y by y hat y to y hat I, for example, this is I yj minus this ij. Okay. Now
Hmm.
when we do
Right.
this, so from here this becomes y hat I, and y hat I which is there, it gets cancelled.
Hmm.
Now,
Okay.
this value of y which is there, it can either be 0 or it can be 1.
Yes.
Y. Okay. So if it is 0,
Okay.
then entire term becomes 0.
Correct.
And when it becomes 1, so finally, just
Oh,
wait.
I think that is why you are using a one there, a symbol one.
Yes, symbol 1. So
Oh, okay, okay,
yeah,
okay,
so finally when we get this, we get the answer like this. It is something like this. The final derivation which is here.
hmm,
Okay, so in the
okay,
entire this, in the entire Jamboard, I think it has got a limitation. So I'll go to the my notebook. So notebook also I'll share with you.
okay,
So what you have to do, Anand, it is only for the understanding part that how this term has come, but the throughout the course,
okay,
for this output layer which is there in any, if it is a softmax, and this is the output layer, and here is A3. Okay, just you have to remember that if it is a softmax function, this is a loss, then loss which is coming, loss is flowing like this.
hmm,
It passes through this layer. That's why we had
right,
taken that.
right.
So here the value of loss which is there, you just remember it is like this. A3 is equal to minus, I'll just check the lecture also. Final value what they have given on this, yes, y hat minus this. So this, what we have found out is the value of, you can write down as y hat minus y. This is important to remember.
Y hat minus Y. Okay.
Or you can write down okay, like what we have written, y hat minus 1. So it is
Hmm.
1
Okay. Okay.
where y is equal to 1 or else 0. Okay.
Okay. But this
Both
is
are
not the
written.
same as what the lecture. Can you go to the lecture slides?
Yeah. Yeah. Lecture, it is the same.
What is it? E thing there? E of
E,
L
E of
in the
L
last
is,
step. In the last step.
yeah, E of L. See, the derivative which is there, the size of derivative what we are getting, it is 3. For example, if the y hat size was 3, so YL by A3 size is also 3, 3 into
Yeah.
1. Okay, so here what they are writing, this 1 which is there, y hat minus 1, 1 minus, if I is equal to j, like for example, if I have taken with respect to, we are taking 3 derivatives, we can see here also. L is equal to 1 minus y1, y2, y3. Otherwise, okay, all values they become 0. So
Hmm.
during the course, Anand, you just remember everywhere you will use, okay, you can use directly this. It will not
Okay.
confuse you. No Madi formula is required for this. In fact, okay, during the entire course, you can use this y hat minus 5.
Okay.
So just to give you an example, for example, your y hat, for example, has come like that day we had taken an example. Y hat has come 0.33, 0.33, and 0.33, for example. And your y value is, for example, 100. So
Hmm.
del L by del A3, you can directly calculate as 0.33 minus 1 is 0.67, 0.33, and 0.3. So without going into the mathematics and anything, we have to remember this function. That At A3, the loss value is this.
Okay, I see.
Okay. In
Hmm,
fact,
hmm,
a professor, if you listen to the lecture, he also mentions that we don't have to remember that this derivative and all that.
okay,
Okay, so this is the important part, that in the last layer, here loss which we are getting is this. Now we are interested in this part. So this is the first part is, I will use the important. Okay, now
okay. So that is
using,
kind of okay. Yeah, please go
yeah,
ahead. Yeah.
okay, Anand, just we will have to remember this, that at the
Okay.
output function, and when
Hmm,
we are flowing through a softmax, it is a softmax. So this is the thing which we get, y hat minus y.
okay.
So now del L by del W3 we can write down as del L by del A3 into del A3 by del W3. This we have calculated. This is y hat minus y. And this will become A3 is equal to W3 transpose into H2 plus B2. Sorry, 3. Therefore, del A3 by del W3 is equal to H2. So
Okay.
here will
Yeah.
become
So it's H2.
H2. H2.
H2. Okay.
Now del L by del W3 size will be same as W3, and W3 size was 3 into 2.
Okay. This part is again something I didn't understand. Del L
Okay.
by how do you
Uh,
say that it is W3?
See, we what do we use? W3 is equal to W3 minus nu into LW3.
Yes.
Okay. So it means the size of this has to be equal to this. Then only we will get the same size matrix.
Okay. Okay.
Okay. Because we are doing the matrix subtraction. Na?
Right. Right. Right.
We are
Oh, okay.
multiplying by a scalar, and then we are
I
doing
see.
subtraction.
Oh,
So this
okay.
has to
Okay.
be this.
Okay.
Yeah. So same
Okay.
size as of W3. Okay.
Okay.
So W3 size is 3 into 2. Y hat minus Y size is Y hat minus Y size is what? 3 into 1. And
Hmm.
H2 size is what? Sorry, in this case was 2 into 1. In our case, 2 into 1. And H2 size is 3 into 1. So how to get
Hmm.
a 3 into 2 matrix? We can do H2 dot Y hat minus Y. Then we get 3 into 2 size. So this
3
becomes,
into 1.
and this will become transpose,
Ah,
and this will,
transpose. Okay. Okay.
okay. So this how we have got
Oh,
del
okay.
L by W3. So
Okay.
this is the,
This sounds very complex, Lilith.
no, no, not complex. Malay, once you understand, you will not forget. And it is basically, I'm telling you, only for understanding. When we are doing, when you'll go to PyTorch and all that, that dimensions we have to take care of in PyTorch and all that also.
Okay. Yeah. No,
Okay.
the one additional problem that happened to
Yeah.
me is the website you sent me. I was
Yes.
referring to the back propagation chapter in that, and
Okay.
there are a few derivations there. There are actually many derivations,
Okay.
and while I was watching this, I kind of forgot what I learned with you.
Yeah.
So
No, that's why the notations which are there, na? The notations in all the sites will be different. The notations which are there,
hmm. Okay,
especially in the Western, they use different notations. So this
okay,
we,
I will use only this. Uh,
yes, yes. For understanding part, you use this, okay? Then you will understand. So we have found del L by W3 is equal to H2
hmm,
into Y hat minus Y transpose. Okay. Now we
hmm.
come
Okay.
to del L by del B3. This will be del L by del A3 by del B3, oh sorry,
A
del A
A3 by B3.
del B3. So this we have calculated y hat minus y,
Hmm,
and
hmm.
A3 is equal to W3 transpose into H2 plus B3. Therefore, this will become 1.
Right.
Okay.
Okay.
Now again, we use the same principle of making the sizes. So this size has to be 3 into 1,
Hmm, hmm.
B3 size. Y hat
Okay.
minus Y size is what? 2 into 1.
2 into 1. Yeah.
Now, okay. No, sorry. B3 size is 2 into 1. B3 size is 2 into 1. So we don't have to do anything. Just del L huh, is nothing but Y hat minus Y. We don't have to do any transpose. Okay.
Yeah. Okay.
Okay. Anand, just give me 30 seconds. There is a call from my office. I'll just attend to
Yeah,
that.
sure.
Hi, Anand. Hello.
Yes, Lalit. Yeah.
Hi. So Anand, till now, things are clear. Okay.
Yeah. Till now things are clear. Yes.
Okay.
We didn't do dou L by W2, right? Uh,
That we will do okay in the next step. है ना?
okay. I think you did. Uh, okay. Can you just go up a little?
Yeah.
Okay. You did only B3. Okay. Fine.
Okay. So we have done this this part. We have done this part. Okay. Now we go
Yes.
to. So here we make this diagram. Loss has come here. We have found A3. Here is H2. Here is A2. and here is W2, here is B2, and here is your H1. This is clear. So
Yes, yes,
del L by del W2 is equal to del L by del A3 by del H2, del H2 by del A2, and del A2 by del W2. Chain rule.
yes.
Okay.
Okay.
So we have found again this y hat minus y.
Y, yes.
Okay.
A3
Now we have
by
got
H.
2, 3. This we have found. This we have to find. है ना?
Right.
So del A3 by del H2 is equal to del H2. A3 is nothing but W3 transpose into H2 plus B3.
Correct.
So this here we get W3.
W3.
Okay.
Yes. Yeah.
H2 is equal to sigma of A2. Therefore, del H2 by del A2 is equal to sigma of A2 into 1 minus sigma of A2. This becomes
Hmm, hmm.
H2 and 1 minus H2. This
Okay.
derivation I had sent you in the morning.
Yeah,
है
you
ना?
had sent me this. Yeah.
Yeah.
Correct.
And del A2 by del W2 is equal to del W2. A2 is nothing but W2 transpose into
A1,
H1
H1. Okay.
plus B2. This transpose we will get H1. Okay.
Yes. Yes.
So we combine these four parts. Therefore, WL by W2 will become y hat minus y W3. Now this part which is there, H2, 1 minus H2 and H1. This we have got.
Hmm.
Now what do we have to remember that this was here H2 and this here is A2. So when the gradient will flow from here, it will flow element wise.
Hmm.
So
Okay.
here we use again numpy ka this multiplication, not the dot.
Hmm. This is the Hadamard product that we said. Okay.
Yeah. Yes, yes.
Okay. Now in this part, when you the NumPy implementation you sent,
Yeah.
you had actually used np dot dot.
No, no.
Uh,
I'll just show you. I
it,
have not. I'll just show you. I'll just show you forward NN. So in the forward NN, I have used dot. Okay.
okay.
And when we do the back, see, this is the part where I have used this here, this multiplication.
Oh, okay. Okay.
Okay, here also and here also at
Okay.
both the
So
parts.
it's the A2, the second one, DA2 equal to DH2. Okay.
Yeah. So now what we will do, now we will try to now find the sizes. Now we
Can
know
can you
the,
can you go can you just go back to the code once?
yeah,
So DH2. Okay, DH2 is W3. So the first part is called DH2.
yes,
Okay,
yes,
and that you are uh, doing a product with multiplying with the other one instead of doing a dot.
yeah,
Okay,
okay,
okay, understood.
yeah. So now what we'll do, we'll try to match the dimensions now. So W2 size, we know that, for example, W2 size is 4 into 3. This is the size.
W2 is 4 into 3. Yeah, right. Somebody has come. 1 second. Huh?
Okay,
Just
okay.
just give me one
Yeah,
second.
yeah.
Hi, Lilith. Yeah,
Right, right.
yeah. Sorry.
So, yeah. So I have written here. See, size of your this W2 is 4 into 3.
Yeah, right,
Y hat minus Y is 2 into 1.
right.
W3 size is 3 into 2.
Okay,
And we have to use the multiplication with this h2 minus 1 by h. So when
correct,
we are passing through this layer, what we are passing, it has to be the same size of what we are passing and what we are getting. So
correct,
size of this entire part here has to match with this.
correct. Yes,
Okay.
right.
H1 size is 3 into 1. 3 into 1. So how to get 3 into 1 size? That we can do W3 if we multiply by W3 is 3 into 2, and if we multiply by 2 into 1 then only we'll get
Yeah, but there is an H2 into 1 minus H2 also, right?
H2. 1 minus H2 is size is same 3 into 1. Here is H2, H, H,
Y-
H2, H2,
hmm, hmm.
1 minus H2 will be become element wise. For example, here if H2 is 0.1, so this will become 0.1 into 1 minus 0.11. 1.
Okay. Hmm.
So here we multiply 3 into 2 into 2 into 1. So we get 3 into 1, and this we are
Right.
multiplying by 3 into 1, and with a what do you call like that product where we get 3 into 1. So now H1 size is 4 into 1, and this size which we have got, it is 3 into 1. So we have to multiply this 4 into 1 with and full transpose. Then we get 4 into 3.
Hmm. Hmm. Okay. Just give me 1 second. Let me.
Yeah, yeah.
Um. Okay. 3 into 1. So this is 3 into 1. Um. Okay. The entire thing you are transposing. Okay. Which is.
Which will become 1 into 3.
Hmm. Hmm.
So 4 into 1 into 1 into 3 becomes 4 into 3.
Okay. Okay. This. I mean, is it always a good idea to do like this? Because it depends on the input, the matrix
Yeah,
sizes, right?
yeah.
Otherwise,
Okay. See, till now, what we are following that we have passed this column. We have passed a column as an input, and we are getting a column as an output.
yeah.
Okay, and that's why now with the hidden layer size, your weight matrix's size will become fixed. Again, you cannot change that. If it is 5, it is 4, it is 3, it is 2. So W1 will become 5 into 4. W2 will become 4 into 3. This will become 3 into 2.
Right. So I'm asking. what I'm saying is you are setting your input to 5 into 1,
Yes, yes.
right? And if you set the hidden layer also to 5 into 1,
Then W1 will become 5 into 5.
then there will be a confusion, right?
No, there will not be any confusion. So just that's why, just to explain, only that's why it took different dimensions so to understand
Oh, okay,
that
okay,
this
okay,
will remain fixed again, this formula.
okay, fine.
Yeah, है ना? Only for understanding part. So from here we have got, for example, we can write down as W2 final as H1 into W3 dot y hat minus y, this product into H2 into 1 minus H2 and entire transpose. And when you take WL by del V2, everything remains same. Only here one major change will come. Here, with respect to H1, it will become 1.
Hmm. Yeah.
So
Okay. So
here,
H1 will go away.
yeah, so again we write like this only by W3 dot H2 and 1 minus H2, and now try to make the size. Now B2 size is what? It is 3 into 1.
Hmm.
Now this is 2 into 1. W3 size is what? 2. So H2 size is
You are not very audible, Lalit. Can
slightly. Book is,
hello?
hello, hello,
Yeah.
hello.
Now it's better. Yeah.
Yeah.
Now it's better.
So
I can hear you.
okay, okay. So we'll go to the Y system now to understand okay, again in the same way. So del L by del B3 is equal to y hat minus y W3 H2 and 1 minus H2. These three terms are there. And B3 size is 3 into 1. This size is 2 into 1. W3 size is 3 into 2. And this we have to multiply 3 into 1. So it means this size has to become 3 into 1. Then only this size will become 3 into 1.
Right. Right.
Okay. So
So
how
it
to
will be
make this
W.
3 3?
Yeah. So it will be W3 Y minus Y hat. Okay.
uh,
I see.
y hat and into H2 1 minus H2. Okay.
Hmm. Okay.
Okay. So here is no transpose because H2 term again we are not using. This H1 term we are not using. That's why this is come. So this 3, 4. Okay. Until now, clear क्या ना?
Yeah. Yeah. Things are okay now.
Hello. Okay. Okay. Now we go to the second. Now we go to output. Now we have to find O1 and V1. Now, the same way,
Hello.
I have
Yeah. I think. Yeah. I lost you in between. And have you written anything more? I can't see.
uh,
Okay. Hello.
Hello, am I audible,
Yeah,
Anand,
I can
now?
hear you well. Yeah.
Can you see also
Yeah,
now?
I can see this. Yeah. Correct.
Okay. So seeing this chain rule, now this term which is there, already we have calculated
Right.
this term.
Right.
Uh, okay. And this was nothing but y had minus y and W3 had come here. H2 over K2 was, this is the term. Okay, this we have calculated.
Right.
And size of this is 3 into 1. Here we have got this. This we can write down as a del L by del A2 also.
Correct. Okay. Yes.
Okay, and this is we have got. Now, del A2 by del H1 will become W2.
Yes. Agreed. Yes.
Del H1 by del A1, again it will become H1
Into 1 minus H1.
into
Yeah.
Y. H1. Very good.
Okay.
And this will become H0.
Okay.
Okay.
Yes. Yeah. Right.
Now let's call this term as A. Can we call it?
Hmm. Okay.
Okay.
Hmm.
Now, now to match the dimensions, W1 size is 5 into 4. This A size which is there, it is 3 into 1. W2 size is 4 into 3. H1 into 1 minus H1 size is 4 into 1. H0 size is 5 into 1. This is clear? So
Yeah.
to get a 5 into 4, this H0 will come here. Okay?
Yeah. Okay. Okay.
Okay.
So H0 has to come in the beginning. Yes.
Yeah. And this size, when you multiply by this, we have to get this is 5 into 1. So I have to multiply
Mhm.
something like 1 into 4, then only I'll get that matrix.
Uh, 1 into 4. Can you repeat that?
When I will multiply 5 into 1 into 4, then only I will get 5 into 4.
Yeah. Yeah. Yes. Correct.
Oh, okay.
Oh, so the
So,
resulting thing, the bracket thing should have 1 into 4 is what you're saying.
yeah. So
Okay.
I do the transpose of 1 into 4, 4 into 1.
Hmm. Hmm. Hmm.
This will give me 1 into 4. So this I need here, this multiplication, I need 4 into 1. So what do? I multiply W2, which is size is 4 into 3, into A3 into H1 1 minus H1. This is 4 into 1. This is will
Hmm.
become 4 into 1 into 4 into 1.
Hmm. Okay.
And when I do the transpose, I'll get 1 into 4.
Okay.
Okay.
Yeah. Okay.
So this
Understood.
becomes clear. Now,
Yes.
similarly, how we had done earlier, del L by del B1, we don't use H0, we will use only this term with no transpose. Because size of B1 is what?
4 into 1.
4 into 1. So this will become W2 dot A3 H1 1 minus H1. So that's how we have calculated for all.
Hmm. Okay.
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 So,
Understood.
so okay. So if we take a diagrammatical presentation, how the loss is flying, this is input. Loss comes here. It gets accumulated here at A3. Size will be of A3 size is of A3. Then it flies through. For finding W3, we use H2. Then this loss comes here at H2, and then it plays element wise. It comes here with the
Hmm.
same
Hmm.
size. Now it will fly through W2, and again it will fly element wise, and here we get the loss.
Okay.
So I
Okay.
will share this notebook also with you. I
Yeah.
think this is,
Right.
and it's my, in this we have written slightly clearly.
Yeah.
Uh,
Yeah. Definitely. Yes. So I guess the main part that I get confused is how to determine the sizes of matrices.
yeah.
That is the main part. Okay. So I will have to be very careful on. Maybe I will have
So
to.
yeah. So in that case, I can give you some sessions. What do? You write like a outer layer. You write hidden layer. We have taken two hidden layers. You just think of only one hidden layer and
Hmm.
input layer. So in the output layer, what we had got? We had got y hat minus y. The size was, for example, 2 into 1. We needed 3 into 2. We multiplied this with h 2 3 into 1 to transpose. This is for the output layer. And when you, this is for weights. When you do for bias, you don't do use any this. You just write down y hat minus y, because bias is 2 into 1. This is clear. When
Hmm.
you come
Yeah.
to the
Okay.
hidden layer, then you will always write h, whatever h is there, for example. So for example, here in this case was your h1, and inside is always a transpose here, and here is weight into y hat minus y, and here is that product.
Hmm.
So this how, if you remember that here it is to transpose and h will come in starting, after that will be weight, then you will remember this.
Okay.
Okay.
Right. Okay.
And this notebook, if you will go through, then this is a basic notebook I just made, okay, just for understanding only, that how
Okay.
we are doing that, okay.
Okay. So these are the assignments are. I mean, these come in the form of assignments, right?
They will come in form of assignments, okay.
Okay.
And in quiz one, basically, uh, there will be one or two questions on these calculations.
Okay.
So what do? You just take some examples. Like in this case, okay, we can solve one example. Like that day we had done. For
Hmm.
example, we say uh, input is equal to, for example, all one. Okay, and output is equal to 1 0 transpose. Okay,
Right.
and all weights of ones and biases also ones. Okay,
Right.
therefore A1 is equal to W1 transpose into H0 plus B1. So W1 is all 1, so this will come, W1 is 5 into 4, so this will come 4
Yeah.
into 5.
Yeah. I think this was the forward one is easier. The backward one, when
Huh.
determining the matrix size, that becomes not size, but determining whether it should be a transpose or that is what is confusing.
Yeah, but okay, when if you will have to calculate, then you have to do the forward propagation also, because you have to store these values.
Right. 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 I agree.
Right?
Yeah.
These values we have to find.
Hmm.
And in
Right.
some case, okay, they will not give you output, they will give you the true Y. For example, here instead of output, this is true Y. They will give you this Y is equal to this. Okay, so we can do
Hmm.
this here. So A1 will become 5 plus 1, 6. This will become very high. I think it will come to 1. Now A2 is equal to,
How did you get one there?
because when sigma becomes high, e to power
Minus six,
minus
right?
6, this becomes approximately 0.
Oh, okay. Okay, you are taking an approximation. Okay,
Yeah.
fine.
Then W2 into H1 plus B2. So W2 is 4 into 3. So this will become 3 into 4. This will become 4 plus 1, 5. This also becomes 1, 1.
Okay. Yes.
Okay.
Hmm.
Now A3 is equal to W3 transpose into H2 plus B2. W3 is 3 into 2. So this will,
B3.
yeah, B3. So this will become 2 into 3. Mm-hmm. 4 into H1. Mm-hmm. We have made some mistake somewhere. H1 is equal to 4, 4 into 3. This is 3 into 4. So this will become this. This will become 4, 4, 4. 4 and 4. Now,
One second. One second.
yeah,
So in the A2 calculation,
yeah.
A2 is W2 transpose into H1 transpose plus B2.
H, not H1 transfer, only H1.
No, in the formula, I'm reading from the formula. A2 is equal to W2 transpose into H1 plus
Yes,
B2, right?
yes.
So W is 3 into 4.
Yeah. So
Uh,
this is okay.
no, that's not okay, right? You can't
No,
multiply.
no, 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 no. Just give me 1 minute. This will be like this.
There is one. Yeah, there is one more one. Ah, okay, okay. Yeah, right. So that is one. Okay.
Yeah, yeah. And here is, again, I have made a mistake. Okay.
Right. Correct.
Yeah. Now we go to H3. H3 is equal to softmax of 4 and 4. When these values are same, then it becomes 0.5, 0.5.
Yes. Correct.
Okay. Therefore, now straight away we can come to W3. W loss over W3 is equal to del L by del A3 del A3 by del W3, and straight away we can use the formula. Formula was what?
Y hat into
H2
uh,
into Y hat minus Y.
minus Y. Yes.
This, and W3 was 3 into 2. This is 3 into 1. This is 2 into 1. So we have to do transpose. So H2 here, H2 which we have calculated, we have to use that. H2 is 1, 1, 1. 1, 1, 1. And y hat minus y is 0.5 and transpose 0.5. So this entire will become 0.5, 0.5.
Yeah, all 0.5s.
No,
No, it's 3 into 2, right?
now
Mm,
3 into 1 and 1 into 2. So we get 3 into 2. Oh, sorry. Okay.
right.
Therefore, W3 is equal to same we get.
W3 equal to W3 minus eta into eta you are assuming as 1, is
Yeah,
it?
yeah, n is equal to 1. Hmm.
Okay.
And now we come to B3.
No, but let me ask you. So
Yeah.
when you are doing this, so this is the first step in the back propagation, right?
Yes, yes.
Uh, so technically we have to go.
Back.
Okay. Yeah, we have to go back completely to calculate W3, right? No.
Yes, yes, yes.
So how did we get W3 now?
No, W3 we assumed na, that all ones. W's all we have assumed. W1, W2, W3, we have assumption.
Okay. So at each. Okay. Okay. Fine. 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 But there are some silly doubts actually. That's the
Yeah.
problem.
No, no,
Yeah.
no problem at all.
Yeah.
So, and now we come to B3. So B3 we had realized it is nothing but y hat minus 5. So it is 0.5, 0.5. Okay.
Hmm.
So
Hmm.
B3 will become B3 which is 1, 1 minus 0.5, 0.5. So this also becomes 0.5, 0.5. See, if you understand back propagation of this network, now, because as you will move forward when you will be doing the CNNs, when you will be doing the RNN, then all this understanding will come handy. Because on all the networks, this back propagation takes place.
Hmm. 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 Okay.
Okay, now we go to
So,
directly.
one second. In the last one, B3 is equal to. Did
Uh,
you actually write B0 there, or no?
no,
What did
no.
you write?
B3 we had calculated. No, B3 becomes y hat minus y. When we had calculated, see here.
Correct. So, why did you actually write there in that line? Come down.
Yeah, yes.
The last line.
Y hat minus y.
Uh,
Because
y hat
y,
minus y. After that, the next line, you
this is the
you you
this is the
wrote
update.
B3.
Update. B3 minus new into this.
Okay, before that you have erased it, is it? The something looks like B0 there.
No, no, this.
Okay, 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 fine. So B3 minus eta into, yes, B3. Okay.
Okay.
Yeah.
Now we come to W2B2. W2B2 also we can straight away use the formula what we had found out. W2B2 what we had found out H1 into W3 y hat minus y H2 into 1 minus H2 transpose. So this we can use again. So for that W3 into y hat minus y we'll have to do. So W3 is what is the size 3 into 2. This is 2 into 1. So here we will get 3 into 1. H1 we had calculated. H1 I think if I'm not wrong it was all ones. And the size of H1 was
Hmm. Yeah. Right.
4. Okay. W3 is 111. 0.5. right? H2 also was 1. So this entire term becomes 0. When this becomes 0, this all becomes 0. So there will not be any update for W2 and P2. And now see conceptually that if your loss has not flown through this layer, if your loss has not flown from this layer,
Hmm.
from then it means the loss will not flow to the B1 also.
Okay.
Mathematically also
Yes.
you can see if the loss is not flowing from here, then it will not flow. So there is no update of this W2 and there is no update for B1.
Okay. How can that happen? In
This is for this example, if we are taking 111, because generally the weight vectors which are there, weight is never initialized as weight is never initialized as 1. Weights you will be initializing like 0.1, 0.1, like this.
hmm. Hmm.
Okay. That's why in the notebook also I have initialized weight differently. Here, if you see,
With random values.
with the random values. Here.
Yeah. Okay.
Okay. So
Okay,
this
can you
kind
go
of
back to
yeah,
can you go
yeah.
back to
Notebook.
the notebook? Yeah.
Yeah,
Just go a little up.
yeah.
Okay, so the H1, okay, we know the W3, we know the Y hat, we know the Y. H2 and H1, from where did we find?
This we had found during forward propagation.
Oh, that is the one we have to use now. Okay, okay.
Yes, yes, this H1. H0 is nothing but input.
Hmm.
Okay.
Okay, understood.
So I'll share this notebook with you.
Yeah,
है
yes.
ना?
Yeah, I will have to immediately follow it up. Otherwise, will get again confused.
Yeah,
Okay.
I'll just send it again.
Yeah. Can you also share the recording if you don't mind?
Yes, yes, definitely.
I don't know how big it will be, but just to
Yeah,
share it in Google Drive, I will have a look at
yeah.
it.
Okay. I will stop recording now. Huh?